The Hypersonic Combined Test Force at Edwards is gearing up for the first flight of the X-51A flight test vehicle in the spring of 2010.
What we are going to do is we're going to take the X-51A WaveRider. We're going to launch that from a B-52 at 50,000 feet over the Pacific Ocean, and then the vehicle is going to drop away. It's going to be accelerated by a solid rocket booster up to about Mach 4.5, at which time the solid rocket booster will drop away and the vehicle and the engine interested is going to ignite and then further accelerate that vehicle up to Mach 6.
The engine being tested on the 51A is a hypersonic scramjet propulsion system.
A scramjet is an engine that has no internal moving parts, that it takes the air in, you mix fuel in it, and it automatically burns. Because of the high speed, high temperature that you get in flight, it now is able to produce a thrust.
Teams of testers have put in years of work leading up to the first flight of the X-51A.
It's a fairly complicated test. The altitude is right at the very top of the B-52 capabilities. We also have chase, so they have to be there as well. The telemetry has to be relayed from Naval Station Point Mugu. We have to have a control room with about 35 people all watching the various telemetry. So there's a lot of teamwork aspects to this whole project.
Testers say the purpose behind this program is to demonstrate the ability to use air-breathing hydrocarbon propulsion in the hypersonic flight regime, which is flight more than 5 times the speed of sound.
What's that a challenge for us and why we need to do the research is that conventional turbine engines are basically limited to about Mach 2.5 or 2.5 times the speed of sound. And it's really tough from the pressure and the heat and the aerodynamic loads on the conventional engines to get anywhere past about Mach 2.5. The scramjet on this X-51 will be able to take in air at flight speeds of over Mach 4 and up to Mach 6 and take air from the atmosphere, burn it, and then use it for thrust. And if we get that capability, we'll be able to apply this technology to many other flight applications that the Air Force might use.
The testing of hypersonic technology at Edwards is not new. There was the X-15 program that first flew in 1959, and there has been very little other activity since. But today's advancements in technology are giving testers a new edge.
Well, we've been working on scramjets in the United States Air Force for the past 50 years. Matter of fact, there was a program back in the 90s called the National Aerospace Plane that worked on scramjet engine technology before. But because of those high pressures and those high temperatures that I talked about with scramjet engines, the technology of the materials and the propulsion and how to handle those high temperatures was not ready. So we have finally come to the point of doing propulsion research that we're ready to go fly a scramjet engine and demonstrate that it's a very viable propulsion concept to power aerospace vehicles.
As scramjet technology is developed, testers believe that in the near future it could be used to aid warfighters as a weapons delivery system. Further down the road, it is believed it will make space access easier.
The far-term application really is all about spacelift, and this is the one that I think in the Air Force Research Lab we're most excited about. And I like to tell people, if you think about the shuttle is basically how we get a lot of our payload up into space now, replenish the space station and things like that. The shuttle has to carry along all of its oxidizer for the propulsion concept, so it's a pure rocket system. If we could incorporate scramjet engine technology in our spacelift systems, as the rockets or the vehicles that go up through the atmosphere, they could acquire the air through air-breathing engines through the atmosphere, and you wouldn't have to carry those tanks to carry oxidizers. So therefore it makes the propulsion cycle much more efficient. And then instead of carrying oxidizer, they could carry more payload to space.
Teams from the Air Force Flight Test Center, the Air Force Research Laboratory, Boeing, the Defense Advanced Research Projects Agency, NASA, Pratt & Whitney Rocketdyne, and the U.S. Navy are working with a Hypersonic Combined Test Force on the X-51A WaveRider test project. For Mr. Johnny Armstrong, who has worked with hypersonics at Edwards since the early 1960s, the X-51A project is one of the highlights of his career.
For me personally, this is a real reward towards the end of a career where I've worked hypersonics and now all of a sudden this program is here. I'm able, after 32 years since the X-15 last flew, I'm able to go back into a control room,